Hello everyone. Let's finish the last two questions that you have in the practice exams. For the last two questions, it will ask something about the sequence. Okay, so the for proving if the sequence is increasing or decreasing. Let me recall a little bit about definition. Okay, so that means if you have the increasing sequence, if you have increasing sequence. That means your sequence keep getting bigger and bigger over time. That means the previous element should be less than the next element. Okay. If you have the increasing sequence, that means the elements in your sequence getting smaller and smaller over the time. So that means the previous element should be larger than the next element. Okay. So from here, you can have that the quotient between an plus one and an will be larger than one. Okay, from this one, I divide both sides by an. Okay, and from here, I will divide both sides from an's again, and I have something less than one. Okay, and remember that the ratios over here just apply if an is a positive element. If an is a positive sequence. Okay, if an is positive, because over here, starting from the definitions of increasing sequence and decreasing sequence, when you consider the ratio between these two elements, you have to divide both sides by an. So if an is negative, the, the directions of your inequality will be changed. So we just have this ratio when an is a positive sequence. Okay, so let's start with the first one. Okay, so the first question, the question wants you to show to explore if this sequence is increasing or decreasing. So we have that is an is n plus one divided by 4 to the n. So that means the element at the n plus one index should be given by n plus one divided by 4 to the n plus one. Okay. This is the rules of your sequence. At the n position, you plug in n to find the element at the n index position. For the element at the n plus one positions, you will replace n by n plus one. Okay, so now I consider the ratio between these two elements. I have n plus 2 divided by 4 to the n plus 1. Okay, this is n plus 1, so I have n plus 2 divided by n plus 1 over 4 over 4 to the n. Divide the divisions by a fraction can be rewritten as the multiplication by reciprocal. So you're gonna have n plus 2 divided by n plus 1 times 1 over 4. Okay? And what can we say about this thing? Okay? From this thing, you're gonna have n plus 2 and plus 1. I mean, you have you have to compare I mean, over here, you have to compare your ratio with the number one, okay? So I will try to rewrite my thing in this way, okay? Therefore, I have 1 plus 1 over n plus 1 and 1 over 4, okay? Firstly, I have n plus 2, so I rewrite n plus 2 as n plus 1, and I split the fraction. So n plus 1 divided by n plus 1 gives me 1. And I have 1 n plus 1 over here. Okay. Okay. And over here, I have 1 plus 4 times 1 over plus 1 4 and plus 1. Okay. And you can easily see this thing. This thing is extremely less than 1. And okay, like you have m plus 1 is greater than 2. Okay, therefore 1 over m plus 1 will be less than 1 half. Therefore 1 over 4 times m plus 1 will be less than 1 over 16. So that means the from here, from here, you can say that your ratio is less than 1 over 4 plus 1 over 16, which is strictly less than 1. Okay, so you have shown that your ratio is less than 1. The ratio between any two consecutive element is less than 1. Okay, therefore, if it's less than 1, sorry, if it's less than 1, then you have the decreasing sequence. Okay, okay, since the quotient between two consecutive numbers is less than 1, so we have the decreasing sequence. Next thing, the question want you to explore if the sequence is bounded or not. Okay, so if you want to show that the sequence is bounded, you have to show that the sequence is bounded from below and the sequence is bounded from above. Okay, um, so over here you can easily see that an is n plus 1 divided by 4 to the n. Okay, you can easily see that n plus 1 is positive because your index is starting from 1. So whatever values n you have, when you're adding 1, this thing should be strictly positive. The same thing for 4 to the n. 4 to the n is the exponential function, so it's only positive. Therefore, if you take the product, if you take the quotient between two positive number, you should have positive number. So your sequence is bounded from below by 0. Okay. Okay, so can we find the upper bound for the sequence as well? So from here, I would say that n is less than 4 to the n, right? Because this is the linear function, this is the exponential function, then the exponential function is only larger than the linear function. Or if you want, you can check with several values, like if n is 1, you have 1 less than 4 to the power of 1. What is true? If you have 2, you have 2 less than 4 to the 2. If you have 3, you have 3 less than 4 to the 3. And you see that on the left side, you just have the linear function. So when you increase one, you just increase 1 unit for each index. But if you test with the right-hand side, because the right-hand side is the exponential function, so when the index is 1, you have 16. I'm sorry, when the index is 1, you have 4. When the index is 2, you have 4 square. When the index is 3, you have 4 cube, which is extremely large compared to 1, 2, 3. Okay. The next thing is 1 is also less than for n for sure, because n is starting from 1. Okay, so what for any values of n, 4 to the n is always larger than 1. So from here, okay, if I add term by term, I can say that n plus 1 will be less than 2 times 4 to the n. Okay, n plus 1. Okay, n plus 1 will be less than 4 to the n plus 4 to the n, which is 2 times 4 to the n. And from here, as I divide both sides by 4 to the n, I have my sequence is bounded from above by 2. Okay, and that means my sequence an is bounded from below by 0 and from above by 2. So my sequence is bounded. Okay, and last thing, for the questions, for part 3 of the question wants you to explore if the sequence is convergence or divergence. So to do, I mean, over here you have explored some properties of your sequence. So you can use the property to conclude the convergence of your sequence. So remember that in the lectures videos, I have discussed that if you have increasing sequence and your sequence is bounded from above, then your sequence should be convergence. Similar, if you have the decreasing sequence and your sequence is bounded from below, your sequence should be convergent as well. And if you want to have the better understanding why we have these two theorems, then you can go back to the lectures videos on sequence topics. So over here, I have shown that my sequence is decreasing. And I also show that my sequence is bounded from below. Okay, so if sequence decreasing and bounded from below, then it is convergence. Since an is decreasing and bounded from below by 0, then an is convergence. Okay, so over here, remember that you don't need the sequence to be bounded from both sides. You just need the sequence to be bounded from one side. In this particular question, because your sequence is decreasing, then I just need the lower bound for my sequence to conclude that my sequence is convergence. For instance, even if my sequence does not have the upper bound, for instance, I have some different function, different sequence, and my sequence is not bounded from above. But the point is, as long as I can find some lower bound for my sequence, then I can use these two statements to conclude the convergence of my sequence. I mean, for part 1, I forgot to mention, for part 1, if you don't want to consider the ratio and do some kind of explanation to obtain the bound to conclude that the ratio is less than 1, you can try to approach from this way. Okay, over here, the other way to approach is you can set up f of x equal to n equal to x plus 1 divided by 4 to the x, where x is starting from 1, because the index of your sequence is starting from 1. Okay, so you can consider the similar function, the function that is similar to your sequence, and then you find f primes of x. Okay, and if you can show that f primes of x is less than 0, that means your function is decreasing, and if your function is decreasing, your sequence is decreasing as well. So this is the other way to work with part one if you don't want to do some uh, ratio tests for I mean, if you don't want to take the ratio between two consecutive numbers. Okay. The For question number nine, I want you to evaluate the limits of the sequence. Okay, and it is most likely that I will ask one question using the squeeze theorem. Okay, so let me record the squeeze theorems. The squeeze theorem saying that if you have some sequence that is bounded by the other two sequence, okay, and if the lower sequence and the lower bound sequence and the upper bound sequence have the same limits, then it forced this middle sequence to have the same limits. Okay. So over here, I want to evaluate the limit of this sequence using the squeeze theorem. And remember that when you see the sine or cosine function, one of the possible inequality you may have is sine of x is always between -1 and 1. Okay, because the point is you need to find some lower bound sequence and upper bound sequence, so you should have some inequality that have the lower bound and the upper bound. And for the sine or cosine function, this is one of the most likely inequality you're going to use to obtain the lower bound sequence and the upper bound sequence. Okay, so because the value of psi is always between 1 and -1, so I can say that psi of 5n is between -1 and 1. So even if I multiply 3 to the n to every terms, my inequality will reserve. Okay, from this thing, I mean, this thing is always true. And now I multiply every terms by 3 over n. Okay, so I have -3 over n less than sine of 5n times 3 over n less than 3 over n. And you have to notice that the middle terms over here is actually my sequence. Okay, so now I just need to find the limits of this thing. I just need to guarantee that the limits of the lower bound sequence and the upper bound sequence are the same. So limits when n tend to infinity. Okay, let me write that over here. The limits of n tend to infinity is of -3 to the n is just 0, because you have a fixed number and your denominator is become extremely large. So you have a fixed number divided by something extremely large, you're going to have 0. The same thing for the upper bound sequence. You have fixed number divided by something extremely large, you also have 0. So over here, the sequence that we want to evaluate the limits is bounded between these two things. And these two things have the same limits when n approaches 0. So by the squeeze theorem, I have that the limits when n tend to infinity of sine of 5n and 3 over n is 0. Okay. The next question gives you some limits. Okay. And remember that you can use the L'Hopital rules for the limit of the sequence as well, because the sequence is just the function in terms of the natural numbers. Okay. The function, it's just the sequence, it's just the function in terms of the natural numbers, where n is 1, 2, 3, 4, 5. So you can really much use the L'Hopital rules. So over here, the limits of an when n tends to infinity is the limit when n tends to infinity is of 3n squared plus 3 divided by 4n cubed plus n plus 1. And if you plug in infinity, you're going to have infinity over infinity, so you can use the L'Hopital rules. Okay, and it allowed me to translate the quotient between two functions into the quotient between two derivatives. I have 6n. Okay, derivative of 3n squared is 6n, derivative of 3 is 0. Derivative of 4n cubed is 12n squared. Derivative of n is 1. Derivative of 1 is 0. And over here, again, if I plug in infinity, I still have infinity over infinity. So again, I would use the L'Hopital rules. I'm gonna have the limits when n tends to infinity of 6 divided by 24n, because the derivative of 6n is 6. Derivative of 12n squared, I bring 2 into the front, I have 24, and I have n. Derivative of 1 is 0. So I have 6 divided by 24n. And when n tends to infinity, I have a fixed number divided by something extremely large, so I have 0. Okay, so I have obtained the limit of this sequence using the L'Hopital rule. Okay, so this is everything that you need to know for the second midterm exam. And if you have questions, please feel free to ask me through email. Okay, and I will see you again in the lecture video.